Okay guys, so this video is on optimization. Remember optimization is, well, the whole point of it is to find the most efficient way, so therefore using the least amount of material or whatever it is in order to construct a problem. So in this case what I have is I have a garden patch and I want to find the minimum amount of perimeter of, say, fencing around this garden patch to keep, I don't know, animals from stepping on it or whatever, and I want to keep my costs down. So the important things to remember is that the question normally gives you crucial information at the start. They give you something. So here the area of this whole thing equals 4 meters squared, and this is composed of two identical rectangles and a sector. Now, the best place to start is to say, well, it says find the minimum perimeter, so I need to get everything in terms of my perimeter. So my perimeter has two x's plus 1, 2, 3, 4 y's, yeah? And it also has this arc length here. So remember, our arc length formula is the radius, which in this case is x, obviously, and our angle in radians is pi over 2, is 90 degrees. So this equals x pi over 2. So plus x pi over 2. Now the problem I have with this is that I've got two variables. I've got x and y. I need to get rid of y and make it in terms of x in order for me to be able to differentiate it, which, as you know, I differentiate it, I set it equal to 0 at stationary points, and that means I can find my maximum and minimums, okay? So, we've got a bit of information here, like I say, which we can work with. So we can say that 4 equals, well, the area of this plus the area of this. This is x times y times twice. So 2xy. Plus the area of the sector, which is a half r squared theta. So plus a half x squared, because that's our radius, theta is pi over 2. So this means I've got 4 equals 2xy plus x squared pi over 4. Rearranging, 4 minus x squared pi over 4 equals 2xy. Make the denominators the same. Yeah? Equals 2xy, and I need to get y equals, so y equals 16 minus x squared over pi, minus x squared pi, dividing both sides by 2x, so that's 8x. So I can now sub this y into here to get a new expression for p, all in terms of x. So p equals 2x plus 4 times 16 minus x squared pi over 8 plus x pi over 2. So let's simplify this up again. So this is 16 minus x squared pi over 2. So that needs an x there. 2x plus x pi over 2. Now again, make the denominators the same. All I'm doing is making the denominators the same. So if you need to pause this tape or rewind them, please feel free to do so. Over 2x. Okay. Now we can simplify this up. So this cancels with this, and I can divide everything by 2. So I get 2x squared plus 8 over x, which equals 2x plus 8 over x. So I've got p equals 2x plus 8 over x. Yeah? Now I can differentiate this. Now this is the same as this. If I differentiate this, I get dp over dx equals 2 minus 8x to the minus 2 equals 0 at stationary point. Yeah? Which is the whole point of what we're doing, because we're trying to find the max, or the minimum, sorry, perimeter. So if I rearrange, this gives me this, and therefore I get x squared equals, rearrange again, pause the tape if you need to. So therefore x equals plus or minus 2. But as x is a length, we know that x must be greater than 0, so x must be 2 meters. Okay? We're not finished. What we could do is we could check our nature to make sure that we've found the minimum. So check nature, and I could differentiate my p again. So d2p over dx squared equals, if I differentiate this again, I get 16 x to the minus 3, yeah, which at x equals 2 d2p over dx squared would be greater than 0, so therefore would be the min. And if I put in that x equals minus 2, I would get a negative number, which means we would find the max. Let's say theoretically that x could be greater than greater than that. That x could be less than 0. Then we would find the max, and of course the question is asking for the minimum perimeter. So let's clear this up. The question asks for the minimum perimeter, so I need to plug my x back in. So it's a good idea to write p min, yeah? P min equals 2 times my value of 2 plus 8 over 2, which equals 4 plus 4, which equals 8 meters. And that's done. Okay, so now I've got this second problem which is asking, find the maximum volume of a cuboid tank made from 54 meters squared of sheet metal with no top, with square opposite ends. So it's a really good idea to draw this problem because this sounds nasty. So I've got a tank, it's got no top, yeah? That doesn't look good. There, it's got no top, right? But it has got a base, so let's draw that base. So the S surface area, S, equals 54 meters squared. So remember, they're giving you a bit of information. Let's say that this height of the box is x, and it says square ends, so therefore this value must be x, that must be x, that must be x. And we'll call this length y then, yeah? So again, the question is asking for the maximum volume, so let's express this in terms of our x and y's at the moment. So the volume equals the base, which is x times y, times the height, which is x. So therefore v equals x squared y. I need to find what y is, don't I? Because again, I've got two variables here. So this is where I can use this surface area problem. Yeah? So the surface area equals 54, which equals, well, I've got two of these two of these square ends here, so that's 1, so that's 2 times x squared, yeah? I've got two of these sides here, which is length y times x, so that's plus 2xy, sorry. And I've got the base itself, which is x times y, so plus x times y. Right? So, if I then rearrange I can get things in terms of y. So 54 equals 2x squared plus 3xy. Implies 54 minus 2x squared divided by 3x equals y. So therefore I can shove this back into here and sub that in. So I get v equals x squared 54 minus 2x squared 3x, which equals 54x minus 2x cubed. So that's x squared over 3x. So this will give me 54x minus 2x squared over 3. And it's probably best, if I'm going to differentiate this, to split this up. So 54 divided by 3 is, what, 18? So that's 18x minus 2 over 3 x squared. Just realized that this should be a 4, because 2 times 2, that should be a 4, so that would cancel to a 3, and that would cancel to a 3. Sorry about that. Right. So v equals this. So if I extend my page, I can now differentiate this, because I'm trying to find the maximum volume. So this is 18 minus 2x squared equals 0 at stationary point. Yeah? Always at stationary point. Rearrange. 18 equals 2x squared implies 9 equals x squared implies x equals plus or minus 3 meters. Because we're talking about length, x can't be negative, can it? So x must be greater than 0, so therefore x must equal 3 meters. If I wanted to check that I'd found the maximum, again, check nature. d2v over dx squared. So I'm differentiating this again, yeah? So this is minus 4x, yeah? And at x equals 3, d2v over dx squared would be less than 0, so therefore provide me a max. And similarly with the other problem, if I use the minus 3 meters, that would give me a positive value, which would give me a minimum, which isn't what the question asked for. So, just to finish off, it asked for the maximum volume, so V max, and I'm just going to substitute in my x equals 3 value. So V max equals 18 times 3 minus 2 over 3, 3 cubed, which equals 36 meters cubed, because we're talking about volume. And there we go. It's done.